Welcome to this Intel and VMware Executive Perspective discussion. I'm Roberto, Senior Director and Technologist for the Network and Security Business Unit at VMware, and it's great to be here today with Tarun Viswanathan, Principal Engineer in the Network Platform Group at Intel. Today we want to talk about modern applications and how they are evolving and driving new operational and monitoring challenges. These modern applications are dynamic and complex, built on highly distributed cloud-native architectures. They need a modern underlying network. This modern network should be abstracted and made transparent to developers and lines of business, and serve the needs of the business, including agility, flexibility, openness, security, and elastic scale. A modern network must also put the end-user experience first by providing the right level of visibility and adapting to match the end-user journey. Let's discuss about the visibility component. When we talk with customers, we hear that a lack of correlation between the virtualized overlay and physical underlay networks makes it difficult for the operator to manage the overall solution. Traditional monitoring tools do not provide to be effective in case of network congestion and resource contention in a modern application environment. Tarun, what's your view and how do you see the infrastructure evolving to meet these requirements?
Thank you, Roberto. Let me cover that. NetOps or network operations is essentially a set of activities that enterprises and service providers rely on to monitor, manage, and respond to alerts on their network's availability and performance. Utilizing telemetry, logs, and alerts from network devices helps detect issues with the environment and enables them to be addressed appropriately. And ideally, this would be done as part of an automated process, thus enabling the concept of self-healing. In the fixed function appliance model, where the entire stack is dictated by the network function provider, the ability to gather all necessary telemetry and alerts is relatively straightforward. And decisions typically revolve around how much telemetry and what kind of alerts need to be turned on. But with the shift to virtual and containerized workloads, new challenges arise in collecting and correlating all the necessary telemetry to determine health of the network function and the service it provides. With the shift to cloud-native architecture and virtualized network functions, telemetry and alerts from the server platforms the network functions run on are a critical input into determining the health of the server and in turn its ability to host a critical service. Without this telemetry, the network function would not be able to determine if the deterioration of the health of the server is in some way responsible for the deterioration of the service it provides. Telemetry data from hardware platforms can be added to data collected from network applications and data flows, correlated and compared against business policies to provide real-time visibility and historical insights into the health of the network function. This, enabled by an automated workflow, results in faster issue resolution, ultimately resulting in improved throughput and reliability. Telemetry capabilities in Intel platforms enable intelligent closed-loop solutions that are reactive, proactive, and predictive, delivering new levels of efficiency for IT and network infrastructure. In addition to the platform telemetry, getting access to granular network telemetry is key. In-band network telemetry is a technology that uses data planes or smart devices to insert and collect per-packet telemetry data for granular, highly accurate network visibility and improved reliability. Additionally, Intel's Deep Insight Network Analytics software helps visualize every packet's path to satisfy the four ground truths for every packet in the network and server. How did the packet get here? Why is the packet here? How long was the packet delayed? And why was the packet delayed? This gives you a very granular level of observability of your network. Intel is working closely with VMware to enable the use of these technologies to increase observability in this new multi-cloud hybrid world and reduce complexity in troubleshooting. Back to you, Roberto.
Thanks, Tarun. These are pretty spot-on capabilities. When it comes to VMware, thanks to NSX, the SD-WAN Edge Network Intelligence, and the vRealize Network Insight, we offer a comprehensive view into what is and what's possible. Now, network operators can predict and automate detection of issues before an outage occurs, and correlate network issues to application SLOs. The broad visibility in this heterogeneous environment represents a key advantage. It gives the ability to run continuous validation of business policies across virtual and physical infrastructure. Network operators can monitor end-to-end connectivity for remote sites, data centers, or public clouds. From a single vantage point, user activity can be tracked from their locations into the data center where an application is hosted. One of the benefits of a self-healing network for customers is certainly its improved operational cost. With a traditional network, tickets are open and processed, manual troubleshooting and remediation actions are taken, involving multiple people across different teams. The result is a very complex workflow which may last days or weeks. With a self-healing modern network, automated remediation and elastic autoscale replace the manual operation, speeding up a problem resolution from weeks to hours or even minutes, reducing the OpEx cost and preventing major outages. Well, Tarun, exciting times indeed. We are looking forward to collaborating with Intel to deliver on the vision of a modern network which puts the applications and the user experience first.